Hi, hello, welcome to my class on foundation class on units and dimensions, physics. Actually, this physics is the study of natural phenomena which is based on measurements. A physical quantity which is one which has got a precise definition and which is used for explaining natural phenomena. So, we are discussing about physical quantities and units now. Discussing about physical quantities and units. Physical quantities and units. In this, physical quantity should be amenable for measurements either direct or indirect. In this, unit is a standard quantity of same kind with the physical quantity is compared for measuring it. For example, if length to be measured, we compare it with the standard meter scale. Magnitude of that physical quantity, if you take x is equals to n into u, where n is the real number and u is the unit of measurement. For some physical quantities, there may be only number of one no unit. Number is there, no unit. Refractive index, specific gravity, and all these things. So here n we are taking as a real number. N is a real number and u is nothing but unit of the measurement. U is the unit of the measurement. Unit of the measurement. Okay. Coming to the point, fundamental and derived units. What is exactly fundamental unit? Fundamental unit and a derived unit. What is first we'll see what is fundamental unit. Nothing but usually physical quantities we know mass, length, time, mass, length, time. We'll call these are fundamental physical quantities. And the units of these fundamental physical quantities are called fundamental units. So, units of these fundamental physical quantities. Fundamental physical quantities, we will call it as fundamental units. Fundamental units. You have any doubt is there in this? We'll talk about a physical quantity and its formula, and we will also give its fundamental unit for that. So any physical quantity which can be derived from fundamental physical quantity is there, that we will call it as the derived physical quantity. Now, what is derived unit we will discuss. What is derived unit? What is derived unit? Derived unit is nothing but, first we have to know derived fundamental quantity. Before that is any physical quantity if you take, that can be derived from the fundamental physical quantities. So this fundamental physical quantity, if you know, from that you can derive another physical quantity. That is called as derived physical quantity. So physical quantities derived from the fundamental physical quantities are called derived physical quantities. Derived physical quantities. And units of these derived physical quantities are called derived units. What are derived units? The units of the derived physical quantities are called derived units. Derived units. Got the point, right? So, What is the fundamental physical quantity? Fundamental physical quantities are nothing but mass, length, time are called fundamental physical quantities. The units of fundamental physical quantities are called fundamental units. And coming to this point, derived units, nothing but the quantities derived from the fundamental physical quantities are called derived physical quantities, and units of the derived physical quantities are called derived units. Got it? Now we have examples. One example is speed. Speed in example which has a meter per second is the unit. Acceleration is there. Acceleration which has meter per second square is the unit. Force is there. For that, kilogram meter per second square is there, is the unit, right, etc. These are nothing but derived quantities. Speed, acceleration, force, these are derived quantities. And units, this meter per second, we are writing meter per second square, kilogram per meter square, meter per second square. This we will call it as derived units. So what is meter? Meter is the fundamental quantity and meter per second is the derived quantity and speed is the derived quantity, right? So what is the basic of this fundamental unit is mass, length, time. These are the fundamental physical quantities, and the units of these fundamental physical quantities are called fundamental units, and the quantities derived from the fundamental quantities are called derived quantities, and the units obtained for the derived physical quantities are called derived units. Okay, so now examples for such kinds: derived quantities speed, derived quantities acceleration, derived quantities force, and their units are called derived units. Okay. Now we'll see the basic units of units, SI units of mass, length, time, temperature, electric current, luminous intensity, and quantity of matter, and all these things we'll see. Units of system. Now the topic is units of system. Units of systems. System, not system, systems. First we'll see CGS system. CGS system. In this, length, mass, time, we'll see their units. Length will be measured in centimeters, mass in grams, time, seconds. These are the units. In FPS system, length, mass, time will be discussed. In that, length we will discuss in foots, mass we will discuss in pounds, that is LB, time we will discuss in seconds. Okay, coming to the point, we have a most important system, another system, that is MKS system. MKS system. In MKS system also we have the discussion about length, we will discuss about mass, we will discuss about time. Length in the MKS system, measured unit is meters, and mass will be in kilograms, time in seconds. Moving on to the SI system, we have SI system. In SI system, length will be in meters and mass will be in kilograms. Mass will be in kilograms. Time will be measured in seconds. Temperature will be measured in kelvins. Electric current that will be measured in amperes. Capital A is the symbol for amperes. Luminous intensity can be measured in candela CD. And usually in chemistry point of view, quantity of matter in moles. Quantity of matter will be measured in moles. So now you are observing on the screen board, that is CGA system. We have length, mass, time. Length in centimeters, mass in grams, time in seconds. In FPS system, we have length in foots and mass in pounds and time in seconds. In MK system, we have length in meters, mass in kilograms, time in seconds. In SI units, length in meters, mass in kilograms, time in seconds, temperature in terms of kelvins. This K is nothing but it's in Kelvin. Capital K is Kelvin. And in electric current will be measured in amperes. Luminous intensity, the units are candela, and quantity of matter is in moles. So these are the list of different kinds of fundamental units and units of some systems. Now we will see definition of some particular units in this discussion. First of all, basic units. I want to give you the definitions of basic SI units. Definitions of some SI units. Definitions of some SI units. In that, first I would like to discuss about some basic units only. Some basic units. In that also, first I would like to discuss meter. Particularly for length, we used to call it as meter. So, meter is the length equal to, actually it is length equal to 1650,763.3 wavelengths. 1 meter is equals to length equals to, this is means you can see here what is the big number here, 1650763.3 wavelengths in vacuum of radiations emitted due to transition between levels of 2p10 and 5d5 of isotope of krypton 86 atom. Krypton 86 atom. It is the distance traveled by light in vacuum. Exactly what is the definition for this mass is, it is the distance traveled by light. Distance traveled by light in vacuum. In what is value? That is 1 by, you can see the number carefully, 2997924 58 seconds. So what is meter? Meter is the distance traveled by light in vacuum in 1 by 299792458 seconds. Okay, this is the definition of meter. Coming to the another one, we have that is kilogram. Kilogram. That is kg. Kilogram is the mass of platinum iridium cylinder. Platinum iridium containing substances with the percentage I will tell 90% of the platinum and 10% of iridium having its diameter equal to its height and each equal to 3.9 centimeters. That is kilograms. So what is kilogram? It is the mass of platinum iridium cylinder. Platinum iridium cylinder having its diameter equal to its height and each equals to 3.9 centimeters. Each equals to 3.9 centimeters. What is kilogram? Kilogram is the mass of platinum iridium cylinder containing 90% platinum, 10% iridium, having its diameter equal to its height and each equals to 3.9 centimeters. Okay, this is the second one. Come to the next one. Second, because length got over. This is mass. Now we'll see time, seconds. Second is the time taken by, this is the nothing but second is the time taken by 9192631. The number is big one, 770. See how much big it is. Vibrations corresponds to the transition between two hyperfine levels. Two hyperfine levels of cesium-133 atom. Cesium-133 atom. So what is second definition? Second is the time taken by 9192631,770. Vibrations corresponds to the transition between two hyperfine levels of cesium-133 atom. Okay, this is regarding the seconds. So we observed the meter, we observed the kilogram, observed the second, basic units and their precise definitions. We will see about Kelvin, candela, Ampere, mole. Now we will see about Kelvin. Kelvin, capital K, right? So Kelvin is the unit of temperature. Actually, it is defined as 1 by, this is nothing but 1 by 273.16. 1 by 273.16 fraction of the thermodynamic temperature. The thermodynamic temperature at the triple point of water. At the triple point of water. At the triple point of water. So this is the definition for Kelvin. So Kelvin is the unit of temperature defined as 1 by 273.16 fraction of the thermodynamic temperature at the triple point of water. Next we will see candela. CD. Light luminous intensity will be measured. So candela is the luminous intensity in a perpendicular direction of the surface of 1 by 6 lakhs 1 by 6 lakhs meter square of a black body at a temperature of freezing platinum. PT is the symbol for platinum. That is 2046.65 Kelvin under a pressure of this is also most important 101325 Newton per square meter. Okay, this is the definition of candela. So what is candela definition? Candela is the luminous intensity in a perpendicular direction of surface of 1 by 6 lakhs meter square of a black body at a temperature of freezing point 2046.65 Kelvin under a pressure of 101325 Newton per meter square is the definition. Actually, it is also the luminous intensity in a given direction due to the source which emits monochromatic radiation frequency about 540 into 10 power 12 hertz, which radiant intensity in the direction is 1 by 683 watt per steradian. So you can also define the luminous intensity like that. Let us move to the next one, that is Ampere. Capital A, Ampere. As you all know, it is the constant current which when passed through each of two parallel conductors of infinite length and of negligible cross section held 1 meter apart in vacuum. Okay, so what is Ampere? Ampere is that constant current, which when passed through each of two straight parallel conductors, two straight parallel conductors of infinite length, and of a negligible cross section, negligible cross section held 1 meter apart, in vacuum, exert a mutual force of 2 into 10 to the power of minus 7 Newton per meter. Force is Newton per meter here. So once again I will repeat, what is ampere? Ampere is a constant current which, when passed through each two straight parallel conductors of infinite length and of a negligible cross section held 1 meter apart in vacuum, exert a mutual force of 2 into 10 power minus 7 Newton per meters. Let us find out what is mole. As you all know, what is mole is the quantity of matter here. This is the unit of matter. Amount of substance which contains same number of elemental units like atoms, as they are the atoms of 0.012 kilograms, means 12 grams of carbon 12 isotope. Actually, this number is also called as Avogadro number, as you are familiar with as constant, and its value which is equals to 6.0220045 into 10 power 23 per mole. So what is mole? Mole is the quantity of substance which contains the same number of elementary units called atoms, as they are atoms in 12 grams of carbon 12 isotope, and that number we will call it as Avogadro constant, and its value is 6.0220245 into 10 power 23 mole inverse. So this is the definition of SI units, basic units definitions we have given to you. Okay. Hope you have observed this session. In this session, we have given you the physical quantities and units, and we discussed about what are physical quantities, what are derived fundamental quantities, fundamental units, derived quantities, derived units, and units of unit systems, CGA system, FPA system, MKA system, SI, Lee system, international units, SI unit systems. What are the units for the length, mass, time, temperature, electric current, luminous intensity, quantity of matter, and all given. And their definitions of some basic units like meter, kilogram, seconds, and Kelvin, candela, ampere, mole, and all we have discussed in this session. I hope you understand this session. The foundation physics units and dimensions topic in the first session I have taken, and the next session I will continue with the large units of length and its continuation in this session. Okay, until have a nice day. Bye bye.